So what is a force? A force is a push or pull on an object. So it could be throwing a ball or kicking a ball, pulling a wagon, pulling on a spring, or a computer that has a force on the desk that it's resting on because it's pushing down because of its weight. And a lot of times we think of force as an actual contact push or pull, so that would be the examples that I just listed. Something has contact with another object, so it's pushing or pulling on another object directly. But there are also things called field forces. And those are forces that are because of something like charge or weight. So the force that keeps objects bound to the earth and give rise to what we commonly call weight would be the force of gravity. So there are other forces at play besides just pushing or pulling something in the common terms that we use. Some other examples of field forces would be the strong nuclear force between subatomic particles. So what you've learned in the past about chemistry and what holds the nucleus of an atom together. So if we have a bunch of protons and neutrons in a nucleus and then electrons around the outside, what holds that nucleus together is what's called the strong nuclear force. And then there is an electromagnetic force between the charges within the atom. So if we have protons with a positive charge and electrons in the orbital outside with a negative charge, there is an electromagnetic force. And there are weak nuclear forces which arise in certain radioactive decay processes. So when we talk about different types of decay, such as alpha decay, beta decay, gamma decay, that would involve those weak nuclear forces. And then there's also a gravitational attraction between objects. So I'm technically attracting the Earth because I have a mass, but the Earth is so much more massive that it's attracting me more, which is causing me to basically be pulled down to the Earth. So what helps us basically describe the different types of forces would be equations and diagrams. So let's talk about some of the laws that we have to describe different types of forces. So let me delete this stuff here. So first we have Newton's second law, and that is that the acceleration of the object is directly proportional to the net force acting on it. And that's directly proportional with a constant mass also. So there we have a constant mass, and our acceleration is directly proportional to the force. And you might have seen in the past it written as F equals ma. So F is our force, m is our mass, a is our acceleration. Force is measured in newtons, mass is measured in kilograms, acceleration is measured in meters per second squared. so that means that 1 Newton, I'm just going to write that up here, 1 Newton is equal to 1 kilogram meters per second squared. So if you have to do any kind of dimensional analysis, that might be good to know. There are also other units outside of the SI units that are the British units, and that's what we use when we talk about our weight. So we usually talk about our weight in terms of pounds, and we can write that as lb. And 1 Newton is equal to 0.225 pounds. And that means that when we talk about weight, we're talking about a force. So when you step on a scale and you're reading your weight, you're actually reading your force. So you're reading your mass times gravity. And in the past, we've talked about gravity as 9.8 meters per second squared. But if we're doing the British units, then gravity would be 32.2 feet per second squared. So when we try and figure out our mass in British units, we actually measure our mass in what's called slugs, what is called slugs. So when we're asking about mass in British units and we're given pounds, we have to divide by 32.2 to get slugs. And the reason I'm multiplying by gravity when I talk about weight is because that is the acceleration that we're using to determine that force. So we have the magnitude of gravitational force, which is called weight of an object. So we have weight is equal to mass times gravity. You might also see that written as the force of gravity is equal to mass times gravity. So let's draw a diagram that would allow us to visualize the gravitational force of an object. So let's say I have a desk here and I have a computer on top. So here's the screen. Here are all my keys. This computer, I'm going to diagram its weight with an arrow. So what I do is I draw the arrow from its center of mass, so about the center of the object, and I draw it in the direction of the force. And the direction of the force is equal to the direction of the acceleration. And when I'm talking about weight, I remember that the force of gravity is equal to mass times gravity, and I know that gravity acts in the downward direction. So this arrow would have a magnitude of this long, which would represent how heavy the object is numerically, and has a direction which is represented by this arrow point. So a lot of times I would write what the weight of the computer is. I don't know. Probably 8 pounds. And if I were to convert that into newtons, I would have to use that conversion that I gave you earlier in the video, which is 1 Newton is equal to 0.225 pounds.